Hello and welcome to episode 33 of the HamCorp Training Manual. In this episode, we will upgrade our blast furnace coils to TPV, kinda, and set up a subnet for ore processing, starting with bauxite. Nichrome coils are almost done. It's finally time to get rid of these canthal coils, and time to put in nichrome coils. I do like this color a lot more than the canthal. And now we can make some TPV. I just need a bit more platinum, but I have the metallic powder dust ready. TPV alloy dust is an EV recipe. Luckily, the recipe for the mixer is not too bad. I had pretty much everything except the EV machine hull, which I've made, and 2 workstations, which I'm working on right now. And TPV alloy being made right now. Once this is done, I just need to blast it. It's only going to take literally fucking forever, but then I'll have my coils. Waiting on the last TPV ingot right now. To cool these, I do need an EV vacuum freezer, but we don't have access to the EV energy hatch yet because that needs tungsten steel, I think. But luckily, we can use a second energy hatch on a vacuum freezer, so 2 HV energy hatches will be able to handle the EV recipe for cooling this. Now, I know I said I was just going to build another blast furnace, but I'm getting really tired of manually crafting things that need a fluid recipe. So I just want to get the fluid pattern terminal as soon as I can. I'm just going to turn one of these into a TPV blast furnace. Obviously, that makes all 3 of the other blast furnaces inactive because it's no longer a valid structure. That's fine because I only need these coils for 4 niobium titanium dust. So. Look at this fucking sneaky fucker, bro. Yeah, nice try, bozo. So I'll see you again when I have the discretizer, dual interface, and fluid pattern terminal. Dual interface, fluid discretizer, and the fluid pattern terminal. Cool. Got my fluid pattern terminal. It looks pretty much exactly the same as the regular pattern terminal. But this allows you to put fluids in the recipes. So for example, let's do the LV machine hull. This needs molten polyethylene, and it places it kind of as an item in this grid. It's not really an item exactly. You do need a fluid discretizer to be able to handle this thing, whatever it is. And of course, it needs more patterns. So we can encode the pattern as normal. And we also do need to hook up this fluid discretizer. I'm just going to do that at the brain. Connected to the main net, which is this outer one, maybe here. Now to demonstrate, I'm going to use this assembling machine, set it to 0. I'm going to put this unnamed dual interface on it. And yeah, this is basically exactly like a regular interface, but it can handle these fluid patterns. And now we can try to request an LV machine hull. And it's going to say it's missing polyethylene because there is no actual liquid polyethylene stored in our system. We also don't have any fluid storage cells. But what we can do here in the chemicals plant is we can hook up a fluid storage bus to the low voltage fluid tank here. And then of course connect it with the rest of the system. So I got a lot of work to do. But once you do that, the system will be able to automatically pull out the molten polyethylene and then put it into the machine in the auto crafting unit. And then we'd be able to make machine hulls no problem. And then I need to keep working on these. There's a lot of these. So quick update. I'm here in the chemicals plant. I've set up a P2P tunnel. Most of the stuff isn't connected. The only thing that is this tank of molten polyethylene. I have a fluid storage bus on here. And I have it set to extract only, so that if I ever put fluids into the applied energetics system, it doesn't try to place it in here if this happens to be empty, because we don't want that. We want this to exclusively be polyethylene from this chemical reactor. I've also set up a connection to the blast furnaces. Here I have 2 ME interfaces. One puts ingredients into this chest, where they are extracted with an item conduit and then put into the input buses using round robin, so it splits it equally. The outputs are then sent through the same conduit on a different channel and put into this interface. And this interface I have set to not be visible on the terminal. because this isn't going to store any recipes. This is just to be able to put things back into the system. This cover version of this interface is the one that actually stores the recipes. I also named it according to my convention. So this is the EBF at EV with a program circuit 11 with oxygen. That's an O.
Approximately 10 hours later.
It has been a long time, but I finally have everything crafted. So I can finally go through the bauxite line and put everything up. There is a quest in the HV chapter, a few quests actually. And this goes through the whole process for processing bauxite. I also made a flowchart, which I showed for a second in the last episode, but now I'm going to actually implement it. So it's a lot of stuff. And it's going to go in this building, the same building where we have the titanium setup. And because it's so complex, I think it's going to be a little hard to explain what I'm doing. So what I'm going to do is I'm going to go through each of these quests. This first quest covers the process all the way up to making the bauxite slurry. So let me implement that much, and then I also need to get a bunch of cells to finish the quest, so that's a good natural stopping point. And I'll explain what I've done up to that point. And then I'll repeat the process for the heated bauxite slurry, and then for the bauxite slag and sluice juice and all of that, and then the final steps. I just got done adding some energy cells to my applied energistic system. I did that in preparation for this subnet that I made, and I realized that I haven't talked about subnets yet. So a subnet is basically a second applied energistics network, and you can allow it to see a subset of your main network. So here I have 3 different networks, and they're color-coded differently. The blue one is the subnet that I use to carry channels around, like I showed before. The red one is our main net. This has everything in it. And this yellow one is new, and it's going to be used as an ore processing subnet. So I've given it a little bit of storage. Currently, there's nothing in here except bauxite, some grossular dust, and sodium dust. The grossular dust is because it's a byproduct from bauxite. So I just moved the storage here, and I've connected it to the system. The sodium I'll come back to. And the bauxite, I manually moved all of our bauxite into this system, but any new bauxite is going to be stored here automatically. So the way I've done that, remember red is the main net. I have a storage bus on the main net connected to an interface on the subnet. So the main net thinks, oh, this interface is a place where I can put things. And because it's an interface, you're putting it into the storage of the subnet. I've filtered what can go in, so it's only bauxite ore, purified bauxite ore. Only because I have that, I guess I can remove that. And I've also changed the priority here to 1000, because any new bauxite ore we put into our main net, we want it to get sent here first. Here I have 2 more similar connections. There's a fluid storage bus on the subnet, and a dual interface on the mainnet. So the subnet thinks, oh, this interface that I'm connected to is a source of fluids. So it can see any fluids that are visible in the mainnet. But for right now, I am going to set the fluid storage bus here to extract only, so I don't put in any new fluids into the system. And finally up here, I have a storage bus on the subnet connected to an interface on the mainnet. That's the opposite of what we have here. So normally, if I didn't set this filter on the interface, this storage bus would be able to see everything inside of the mainnet. And that can be fine, but I want to keep this kind of sectioned off and just have it be independent, not independent, but completely just like firewalled off from the mainnet. So what I've done is I've set sodium dust here as a filter because I need sodium dust as an input to do the bauxite processing. And what it does is it just fills up the interface, this one slot with sodium dust. And now the subnet storage bus can see that 64 sodium dust. And if you take out the sodium dust, it's just going to immediately refill. So that's significantly faster than using, for example, an export bus. Also, an export bus would start clogging these up because I think we make infinite sodium. So eventually this will fill up, and that's a problem. This way it has access to fast stacks of sodium without clogging up all of the storage. So yeah, subnets can be quite confusing, but they're also pretty nice for keeping things separated. For example, like look at this. Like I opened this terminal for the subnet and it's just the things that I need. Eventually I'll expand this for more things like the ilmenite processing, maybe general ore processing, but that might be a separate subnet. I haven't decided yet. Yeah, this is nice. So the subnet goes all the way here to all of these different machines. I've run out of channels. I'll deal with that later. So starting from the left, first we send bauxite into the macerator. This will crush it and produce crushed bauxite ore, which is sent to the chemical bath. It will also make grossular dust, which is stored in this frame drawer. This frame drawer also has a void upgrade. In the back, slightly out of sight, there's a trash can with a filter, but the trash can is to junk any stone dust. So, crushed bauxite ore. That goes to the chemical bath, where it's combined with sodium persulfate. The sodium persulfate is provided through this fluid export bus. When you mix these, you get rutile dust, which is stored here, and you also get purified bauxite ore that gets sent to the mixer. The mixer is filled with water from the reservoir above, and it combines sodium hydroxide dust, quicklime dust, and purified bauxite ore with the water to get bauxite slurry. And that was the first step. In the back here, we have a chemical reactor. This combines water with sodium dust to make sodium hydroxide dust and hydrogen. The hydrogen we're going to void with a fluid trash can. I have to make one. So I've left some space for some logistics to move the quicklime dust around, because the quicklime dust can be recycled. Now the next step is to make heated bauxite slurry. This is pretty simple. It's just combining our bauxite slurry with steam in an oil cracker. Okay, the heated bauxite slurry is set up as well. There's a fluid heater in the back that turns the water into steam. And then the bauxite slurry itself is just sent through a pipe to the input of the oil cracker. And at the end we get heated bauxite slurry. Step 2, pretty simple. Now the next step is probably the most convoluted. We need to make carbon dioxide, which is in a chemical reactor. We need aluminum hydroxide, which we're going to get from outside of this building, and the heated bauxite slurry itself. And that's going to make alumina dust, which is a product, sodium carbonate dust, which is also a product, sluice juice, which is an intermediate product, and bauxite slag dust, which is an intermediate product. And we get calcite dust, but that is going to be used to recreate the quicklime dust. So closing the loop on the quicklime is done in this step, along with a bunch of assorted outputs. Okay, this is going to be pretty hard to see because everything's hidden between machines, so I'll just walk around for this one. Everything is done in this chemical reactor. We supply aluminum hydroxide. This comes from the main net from somewhere. So if we ever run out, this is going to stop, so we need to be kind of on top of that for now. The heated bauxite slurry is going to go from this output hatch into this input pipe. And up here is a chemical reactor being supplied with carbon dust and oxygen gas that makes carbon dioxide, which is put into an input hatch, which you can't see. So all of that stuff is combined in here, and you make sluice juice, and you make a bunch of different things. Originally, I had multiple output buses, but there's no way to lock output buses to a specific output, I don't think. So I just swapped it out for a bigger output bus, and everything fits in here. This, however, is connected to an ME interface. So these products are going to get stored in the subnet storage. One of those products is calcite dust, and over here I have a new chemical reactor that is being supplied with calcite dust, which does a chemical reactor recipe to turn it into calcite. So the quicklime recycling process has been handled. All of the other products will be handled in the next step. And in this final step, we finally get our rutile dust, gallium dust, and other garbage. So the bauxite slag dust processing is pretty straightforward. Just send it to a centrifuge, and that's that. For the sluice juice, there are 2 paths you can take, and they give you different items. So you could just centrifuge it. That will get you iron, copper, tin, nickel, and antimony. But you could also send it to a distillery, which makes sluice sand dust, and then you can electromagnetically separate that. And you will get iron, neodymium, and chrome. I kind of want all of that. So what I decided to do is I'm going to split the sluice juice 50-50 using round robin on an ender fluid conduit. You can do that, right? Yeah, you can. Okay. And all of that I'm going to send back to the mainnet because those are the end products. So here it is, the last step. A centrifuge for bauxite slag dust, a centrifuge for sluice juice with a pump pumping away the trash water that we get, a distillery for sluice juice, also with a pump pumping away trash water, and that's connected to the electromagnetic separator, which zaps the dust and gets us a bunch of stuff. This interface, I need to connect to the subnet. I said before I'm going to connect to the mainnet, but I don't think it matters really. I'm just going to put it on the subnet because it's easier. Everything should now be in storage. There it is. So now we can finally finish this quest if I take out a bunch of the stuff. Cool, so there it is. There is the bauxite processing line. And there's Blood Moon too, so sorry that you can't see anything. I'm also going to change the priority of this storage drawer to 1000 so that the root tile that we get from the centrifuge over there goes into this instead of into the drives. Just to keep things consolidated and not to, I don't know, fragment the system. Now I'm not sure how much energy the system is going to use averaged over time. This could be an issue because I only have one turbo gas turbine powering this battery buffer right now, but seems to be using 2 to 3 amps on average. It could be more. So it might be wise to put in another turbo gas turbine, or maybe 2 even, just so we don't void anything with these multi-blocks. The single blocks are fine, but the multi-blocks could void if they run out of energy. So nice to have this big buffer while I deal with this issue. I'm also going to remove these logistics pipes and replace them with applied energistics, so the root tile can automatically be processed into titanium. That would be nice. Thank you for watching this episode of the HamCorp Training Manual. In the next episode, we will complete the ilmenite processing line, which is much simpler. We will also expand our blast furnace collection and make multiple small innovations on various fronts. Between episodes, we will continue phasing out logistics pipes. If you would like to use the bauxite processing flowchart, it is available on the company Discord channel. See you next time.